So we're going to discuss factoring polynomials that don't apply to the various factoring techniques that we've already talked about. So what happens if I can't factor it as a difference of cubes, I can't factor it as a trinomial, whatever. And just to note, if you're wondering why the video part of me being here, the camera's turned off, it's because all the lights in my office have decided not to work at the same time. So I thought it was better, instead of having some sort of strange intimate setting, to just leave my face out of it. So I'm working by lamplight, and it doesn't really work very well with the camera. But we're going to talk about how to factor polynomials, and we're going to use the factor theorem to do it. So what is the factor theorem? The factor theorem says that if you can find a root that is f of c is equal to 0, so if you can find a root, then you can find a factor. So if you know that there's a number that when you plug it into the polynomial, it gives you 0, then that number is also a factor x minus that number. Okay, so for example, let me just show you an example that we can factor very easily, just so you can kind of see what we're talking about. All right, so imagine that I give you f of x is equal to x squared minus 5x plus 6. Okay, and I say, I know that this factors already is x minus 2 and x minus 3. And that's something you've done for a while now. What this is saying is that if you plug in 2, okay, so you get 2 squared minus 5 times 2 plus 6, then that's going to give you 4 minus 10 plus 6. That's going to give you 0. So essentially what the factor theorem says is that if you can find a number that when you plug it into the function gives you 0, it becomes x minus that number as a factor. Okay, so the root is translated into a factor, if that makes sense, and hopefully it does. If you plug 3 in, same thing happens. You get 9 minus 15 plus 6, and then also gives you 0. So the question then is, how do I find c? How do I know what these numbers are? I mean, sure, 2 and 3 work, but is there anything else that works? And how do you come up with, if you can't factor, how do you come up with the numbers that might work? And the way you do that is by using what is called the rational root theorem. Okay? And the rational root theorem has 2 parts. The first part is that if x equals m, in other words, x is equal to some number, and that number is an integral root of the polynomial, then it has to be a factor of the constant term. So in other words, if you look at a polynomial like this, you look at that number right there, that's the constant term, it has no x's in it. The factors of 24 are the possible roots. Okay? So in this equation, the roots are minus 2, 3, and 4 that actually work. And you'll notice that all of those are actually multiples, or factors of 24. So what the rational root theorem says is, if you want to find out what the possible roots are, they are the factors of this constant term. Okay? And that's because if you think about how it works, if you have x minus a times x minus b times x minus c, you have a bunch of factors all multiplied together. Eventually, there is going to be a term that is going to be a multiplied by b multiplied by c. You see what I mean? And that term is a times b times c. It negative, I guess, because there's 3 negatives, but that is a constant term, it has no x's in it. So the rational root theorem is essentially saying that the last term, the constant term, is a combination of all of the roots multiplied together, so that if you want the possible roots, they are the factors of that last number. Now, they might not all work. 24 has factors that are not minus 2, 3, and 4, right? It also has 6, it has 8. But these roots are the roots, and they are factors of 24, if that makes sense, and hopefully it does. So what does that mean in terms of how we do this? Well, it means that if you have a factor like this, let me just show you, x cubed minus 7x squared minus 4x plus 28 equals 0. the possible roots are 1 and 28, because that's factors. 2 and 14, those are factors of 28, and 4 and 7. And the other possibilities, they're all plus or minus, right? They're all plus or minus 4 and 7, plus or minus 2 and 14, and plus or minus 1 and 28. My advice is to try the smallest ones first. So we go 1 minus 7 minus 4 plus 28. We say, nope, that doesn't work. Then we try f of 2. So we go 2 cubed minus 7 times 2 squared minus 4 times 2 plus 28. We see if that gives us 0. So if we do that out, it becomes 2 cubed is 8. This becomes 28. This becomes 8. And this is still plus 28. And you notice that is 0 because 8 minus 8 and 28 minus 28. So that means that 2 is a root. And that means then down here that x minus 2 is a factor. That's how the rational root theorem works. Once you've determined one root, then you can actually divide to get the rest of them. Okay, so that's the idea, is you just take the constant term and find the factors of it, and those are the possible roots. Now, what happens if you have a number in front of the x cubed or x to the fourth or whatever? And what happens with that, this is the second part of the rational root theorem. What happens with that is the possible roots are roots of this number, minus 3, divided by 2. Okay? You have to look at the possible factors of 3 over 2. Okay? So you would have, for example, 1 and minus 3 over 2, or 3 over 2 and minus 1, or you might have 1/2 and 3, right? Negative or positive. So 1/2 and negative 3, or 3 and negative 1/2. Those are factors of 3 over 2, and so they are the possible roots for that equation. And then you would plug in and see what your numbers, which number works. And it narrows the possible roots, is basically what it does. So you, instead of picking random numbers and hoping that one of them works, you're just picking the factors of that combination of the constant term divided by the first coefficient. So it limits us to those 4, and then we look, and if you plug 1 in, for example, you're going to get 2 minus 9 plus 10 minus 3, and that is 0. So f of 1, if we just try that first value, is going to be a root, because it's 2 times 1 cubed minus 9 times 1 squared plus 10 times 1 minus 3, and that gives me 2 minus 9 plus 10 minus 3, and that gives me 0. So 1 is a root. Okay, and if 1 is a root, then x minus 1 is a factor. That's what it tells us. So that's the rational root theorem. Now, what does that then allow us to do? Well, what it allows us to do is find the other roots by long division. Okay, so how do you do that? Well, if you remember long division, like if I'm going to divide, I don't know, 7 and 343, okay, so we want to figure out how many times does 7 go into 3? It doesn't. So then we go to 34, and we say, well, that goes in 4 times, right? And you get 4 times 7 is 28, and then you subtract. So 34 minus 27 is 6. And then you bring down the next number. So you bring down the 3 and make it 63. And then 7 goes into 63 9 times. 9 times 7 is 63. You subtract, and your remainder is 0. So that's the concept of long division. So that means that 343 divided by 7 is 49. Okay? So the question is, how do I do that with polynomials? So what we do is we look at the factor is x minus 2. So we put that in front. And then we put the whole polynomial underneath the division sign. So you have x cubed minus 7x squared minus 4x plus 28. And then what you do is you say, okay, how do I get x to be x cubed? And the way you do that is by multiplying by x squared. So x squared times x is x cubed. And then you also multiply the x squared by the minus 2, so you get minus 2x squared. And then you subtract. When we subtract, x cubed minus x cubed, that's 0. Minus 7 minus minus 2 gives me 5x squareds. Then I bring down the next term. So I get minus 4x. How do I get x to be 5x squared? I multiply by 5x. So x times 5x is 5x squared. And then 5x times minus 2 is minus 10x. Then we subtract. Okay? So then you're going to you're going to subtract. So minus 4 minus minus 10 is plus 6x. And then you're going to bring down the 28. Oh, you know what? I messed this up. This should be minus 5. So let me just fix that. I messed up the sign there. So this should be minus 5, which gives me minus 5 and plus 10. So that means that this is actually minus 14. That's my bad arithmetic. Minus 7 plus 2 is minus 5. So then I have to multiply by minus 5x. So that gives me minus 14x. Then I bring down the 28. Okay, so then I multiply x by minus 14. And minus 14 times x is minus 14x. And then minus 14 times minus 2 is plus 28. And when we subtract those, we end up with 0. So that means, in terms of what are we actually finding, that x cubed minus 7x squared minus 4x plus 28 is x minus 2 multiplied by this guy up here. X squared minus 5x minus 14. And then what it allows us to do is we can further factor by factoring this quadratic, and it factors as x minus 7 and x plus 2. So that's my answer in terms of when it says factor that cubic. Okay, so if it's factor this, you have to find a root. We found the root to be 2, so that means x minus 2 is a factor. And then, we divided that, got the quadratic, x squared minus 5x minus 14, and then we factored that. So a couple of notes. If any terms are missing when you're doing long division, you have to put a 0 in there as a placeholder. So if this was x cubed minus 7x squared, and then it was just plus 28, there wasn't this minus 4x, I would have to put a 0x there in order to make sure that the process is going to work. And the other thing is you want to make sure that all your terms are in order. So you want the highest first and then the next highest and so on. All right. So that's the method of long division. So the second method is synthetic substitution. And what happens with that is you're going to go and just list the coefficients. So this is a little bit of a quicker way to do this. Okay, so you are doing the same kind of thing, but you're going to bring down the 1 here. Then you're going to multiply. So minus 2 times 1 is minus 2. And then you're going to subtract. So minus 7 minus minus 2 gives me minus 5. Minus 5 times minus 2 gives me 10. Okay, so I'm multiplying again here to get 10. Minus 4 minus 10 gives me minus 14. And then minus 2 times minus 14 gives me 28. And when I subtract those, I get 0. And then what we do is we put the coefficients onto the powers. So we have like the powers of x. So we have x squared, 1x squared, we have minus 5x, and we have minus 14. Okay? So this is a quicker way of doing long division, but if you look back what we did with long division, you'll notice we did the same thing, right? We multiplied by 1 first, 1x, but we multiplied by 1 the coefficients, and then we did minus 7 minus minus 2 to get minus 5. We multiplied minus 5 by minus 2 to get 10, and then we subtracted the minus 4 and the minus 10 to get minus 14. Then we multiplied that by minus 2 to get 28, and we subtracted those. Okay, so if you look at the method, all we're doing is removing all the x's through our long division. So this synthetic substitution is a little quicker. It's just a little bit easier to do. But we're doing the exact same math, and that's why it works, because we're doing the exact same thing. And then we get to here again, you would factor the remaining quadratic, and you'd say that's x minus 7 and x plus 2. Okay? So all we're going to do is practice this. So we want x cubed minus x squared minus 14x plus 24 divided by x minus 2. So if you do it with long division, we'll do that here. And then we'll do it with synthetic substitution. So we have x cubed minus x squared minus 14x plus 24. So the first thing we do is say, how do I get x to be x cubed? And I do that by multiplying by x squared. So that gives me x cubed minus 2x squared. Then I subtract. So when I subtract, I have minus x squared plus 2x squared. That gives me x squared. And then I'm going to bring down the minus 14x. So that means I'm going to multiply this by x. X times x is x squared. And then I'm going to have minus 2x. I'm going to subtract. And when I subtract, this becomes 12x, but negative. And then I bring down the 24. So I have plus 24, and I multiply that by minus 2 and x. But I want to get the minus 12 there, so the number that I'm going to put up here is minus 12. And then I'm going to multiply by the x, like I just said, minus 12x. And then I'm going to multiply it by the minus 2, and that's going to give me plus 24. Okay, minus 12 times minus 2. And that then gives me a remainder of 0 when I subtract. So the answer is x squared plus x minus 12. The other option, if I just sort of draw a line down here, is synthetic substitution. Synthetic substitution says just take the factor, the number that's there, and then list the coefficients. So the coefficients are 1, minus 14, and 24. And then we just draw a line. We say we're going to bring the 1 down first. Then 1 times minus 2 is minus 2. And then we're going to subtract. So minus 1 minus minus 2 is 1. 1 times minus 2 is minus 2. Minus 14 minus minus 2 is 12. And then 12 times minus 2 is minus 24. And when I subtract those, I get 0. So my answer is x squared plus 12x, sorry, plus x, not 12x, minus 12. Okay? Fix that. I forgot my negative again. I'm having a problem with that today, it seems. But that's my answer. Then, if you were trying to factor this thing, so now we know that it looks like this, right? That cubic is really x minus 2 times that. Then you would factor this as x plus 4 and x minus 3. And then times x minus 2. You don't have to do that part because it's just saying divide. But that's the eventual goal, is to get to the place where we have that value. All right, that factored form. Okay, so this says solve this. So the first thing we're going to do is we have to figure out what are the possible factors. Okay, the way we do that is by looking at 20. So 20 has 1 and 20, 2 and 10, and 4 and 5. Those are the factors of 20. So those are our possible roots. So then we just pick 1 first. I always test 1 first to see if it works, because it's really easy to test, and it doesn't, right? Because we get 1 plus 1, that's 2. 2 minus 16 is minus 14 plus 20. So that gives me 34, I guess. No, that doesn't make sense. Just 4. 5, 6. Back up that train. That's just a 6. Where I got 34 from. Then we go f of 2. We try that one next. So I go 2 cubed plus 2 squared minus 16 times 2 plus 20. So that gives me 8 plus 4 minus 32 plus 20. And that is 32 minus 32. If you add 20, 8, and 4, you get 32. So that is 0. So that means that 2 is a root. And if 2 is a root, then that means that x minus 2 is a factor. And if x minus 2 is a factor, then what we're going to do is we're going to divide by that. So we're going to use synthetic substitution because it's quicker. So we're going to put minus 2 there. And then it's 1, 1, minus 16, and 20. Because if you look back up here for a second, those are the coefficients, 1, 1, minus 16, and 20. Then we draw our line. We bring the 1 down. And then we multiply. So we get minus 2, then we subtract. So 1 minus minus 2 is 3. 3 times minus 2 is minus 6. Minus 16 minus minus 6 is minus 10. And minus 10 times minus 2 is 20. And that gives me 0. So what that tells me is my cubic now has become x minus 2 multiplied by x squared plus 3x minus 10. So now I'm trying to solve this equation. Then I look to factor further. So I say, okay, does this factor? And the answer to that question is yes, it factors as x plus 5 and x minus 2. So that leaves me with actually x minus 2 squared times x plus 5, right? Because it's actually a repeated factor. So then if I'm trying to solve this, then the answers are just x is 2 or x is minus 5, because one of those two values has to be 0. If you're multiplying two numbers together to get 0, one of them has to be 0. Okay? So that's the idea. You're just finding the roots first, which are the possible factors, or not the possible factors, they are the factors of this. Once you've found the factors of this last term, assuming that this is 1, then you try them until you find one that works. Once you've got one that works, you say that's a root, means that's a factor. Then you divide, and you then try to factor this. If this factor is great, which it did here, if for some reason, like if this is actually the 4th, then you're going to end up with a cubic here. So if you do that, you might have to do the factor theorem more than once. Okay, but I think we'll leave it at that, and we'll try some questions out of the textbook.